this definite integral of x cubed over 4x squared plus 9 raised to 3 halves. So basically square root quantity cubed. So we can rewrite, let me rewrite this integral as follows: 0 through 3 root 3 over 2 x cubed over this raised to 3 halves. So square root, the halves means square root, inside this is in the form of some square plus another square. Okay, so we have seen whenever we have square root of a square plus u square, then we make substitution u equals a tangent theta. Okay, so let me write in that form. So 9 in the first place, 9 plus 4x squared cubed raised to power 3 dx. Okay, so we are going to make this substitution u equals a tangent theta. For this question, for this part, a is 9 means 3 square, a is 3, and u is 4x squared, 2x quantity square, so u is 2x. So we make substitution, let u equals a tangent theta. So u means 2x, so 2x equals a 3 tangent theta. This substitution will make the radical sign go away. Okay, so we make this substitution, and now we want to convert everything in terms of new variable theta. Okay, for that let's find the derivative of both sides with respect to theta. So 2 dx over d theta, so I want to write in differential form. So 3 derivative of tangent is secant square theta. Okay, so dx is in fact divided by 2, 3 halves, secant square theta d theta. So x is 2x equals 3 tangent theta, so our x is in fact divided by 2, so 3 halves tangent theta, and these limits of integration are for x. Now our integral will be in terms of theta, so we need to convert this in terms of theta as well. Okay, for that we would write in this way: when x equals 0, so we go from here, let me write over here, when x equals 0, the lower limit, let's find the theta using this assumption. So 0 equals 3 halves tangent theta times, so divide by 3 halves both sides, tangent theta equals 0, or tangent theta equals 0, and give me an angle theta for which tangent is 0, and we know tangent 0 is 0, so theta equals 0. That's for lower limit. Now our upper limit is 3 root 3 over 2. So when x equals 3 root 3 over 2, let's work out with this. Then we get from this boxed relation 3 root 3 over 2 equals 3 over 2 tangent theta, and we can cancel. In fact, if we cross multiply, 2 and 2 cancel, 3 and 3 cancel, and we have now tangent theta equals root 3. Now give me an angle theta for which tangent of that angle is root 3. So tangent of pi over 3, tangent of 60 degree, but we have to go for radians, so tangent pi over 3 is root 3, so theta is pi over 3. Then this integral now becomes, this integral is 0 to lower limit, upper limit we just found, 0 to pi over 3. Okay, this will be 0 to pi over 3. On the top we have x cubed. X cubed means, look at this relation, we assume x is 3 halves tangent theta, so x cubed means 3 cubed, 27 over 8 tangent cube theta over, we have quantity cubed by the way, and inside 9 plus 4x square. Let's work on this 9 plus 4x square, square root of 9 plus 4x square. So I want to work here. Okay, so we have square root of 9 plus 4x square. 9 plus 4x square, that's square root of 9 plus 2x quantity square, right? 2x quantity square, and 2x is 3 tangent theta. So 9 tangent square theta, and 9 we can factor 9, and if we take all the way out, 3, 1 plus tangent square, which is secant square, and square root of secant square is secant. Okay, that was the purpose of making this substitution. Now we don't have a square root anymore. So square root of 9 plus 4x square is 3 secant theta, and we have cube outside. So 3 secant theta cube, 3 cube, 27 secant cube theta. And we still have dx here, and dx is found here. Dx is 3 halves secant square theta d theta. Okay, now we have couple of cancellation. I can see secant square 3 cancel, just 1 left now, secant theta. 27 over 8 on the bottom, so 27 cancel, this 8 on the bottom, nothing else. Okay, so let me erase this part. Now we are left with so 0 to pi over 3, 8 on the bottom, 3 halves, so 3 2 times 8, 16, 3 over 16, and in fact we can pull that number outside. Okay, so 3 over 16 outside, tangent cube over just secant. Okay, tangent cube over secant theta d theta. And it's always easier to work with sine and cosine. Now I want to change this in terms of sine and cosine. So 3 over 16 outside. Okay, 3 over 16, 0 through pi over 3, and tangent cube, tangent theta cube. Tangent is ratio of sine and cosine, so sine over cosine cube, so sine cube over cosine cube. And on the bottom, secant is 1 over cosine. When I change this division into multiplication, 1 over cosine becomes cosine over 1, and d theta. Now we have cancellation, cosine 1 and 1 cancel, so 2 of them left. So we have now 3 over 16, 0 through pi over 3, sine cubed theta over cosine square theta. Okay, though this is a quotient of sine and cosine, it works in the way when we have a product of sine and cosine. Okay, whenever we have a product of sine and cosine, if there is odd power, then we want to save a copy from there. It's sine cubed, so we want to save a copy of sine from there and convert the rest in terms of cosine. Okay, and then when we convert everything in terms of cosine, we make u equals cosine, and the derivative of u is sine, so the leftover sine goes in terms of du. So let's do that. So 3 over 16, 0 through pi over 3. So from sine cubed, I want to do sine square, and I want to leave a copy sine theta with d theta, and on the bottom I have cosine square theta. Now I want to convert sine square in terms of cosine square, so this will be a function of cosine, and we let u be cosine, and derivative of cosine is sine, negative sine, but we can manage that as sine. Okay, now sine square is 1 minus cosine square. Let me write that over here. 3 over 16, 0 through pi over 3, 1 minus cosine square over cosine square times sine theta d theta. So we make another u substitution here. Let u be cosine, then du, the derivative with respect to theta is negative sine theta d theta in differential form. Okay, so sine theta d theta would be negative. Okay, so if we multiply negative both sides by -1, so negative is sine theta d theta. So sine theta d theta will be -1 times du. Okay, so we are converting everything in terms of u. By the way, these limits 0 and pi over 3 are for theta. Since we are converting everything in terms of u, so we need to change those as well. So when theta equals 0, go to the original substitution, which is u equals cosine theta. So u equals cosine 0, and cosine 0 is 1. Okay. And when theta equals upper limit pi over 3, we get u equals, again here's the substitution, cosine pi over 3, and cosine pi over 3 is 1/2. Okay, so this integral is now 3/16 outside. Now 0 through pi over 3 becomes 1 through 1/2. Inside, 1 minus cosine means u, so 1 minus u is squared over cosine is squared is u is squared, and sine theta d theta collectively is negative du, so times -1 du. Okay, look at these limits 1 and 1/2. With the help of this negative sign, we can flip. If we get rid of -1, just write positive, then we can change these limits. So 3/16, with this -1 we can write 1/2 to 1 minus okay, how to integrate this? 1 minus u square over u square. We got a fraction, but there is no fraction rule. Let's try to get rid of this fraction in this way. 1 over u squared minus u squared over u squared, which is 1. -1 we use to flip these limits du. Next, 3/16 outside. Let's find the definite integral, and we're going to evaluate from 1/2 to 1. 1/2 to 1. 1 over u squared is same as u to the -2. Okay, when we move this to the top, u to the -2, it's like u to the -2, and when we integrate we get u -2 plus 1 over -2 plus 1. So u raised to -1 over -1, which is negative in the front, 1 over u. So integration of 1 over u squared is basically -1 over u minus antiderivative of 1 is just u. Now we evaluate this function at the upper limit and minus at the lower limit. So that's 3/16 upper limit minus lower limit. Okay, you can use your calculator. Upper limit is 1, so -1 over 1. This -1 minus 1. Lower limit -1 over 1/2. -1 over 1/2. Reciprocal of 1/2 is 2, so -2 minus u is 1/2. Okay, 3/16 outside. -1 minus 1, -2. -2 minus 1/2, both negative, so we have to add 2 times 2, 4, 1, 5, 5/2. -5/2, and is negative, so positive 5/2. It's positive 5/2, 2.5. And 3/16 times 2.5 minus 2, just 0.5, just 1/2. Okay, 5/2 minus 4/2. 2 is 4/2, so 1/2. So the final answer is 3/16 times 2, 32. Final.